So for our first problem here, kind of picking up with the stuff we were doing yesterday, as you look at doing this sort, there's multiple ways you can go about it. Some people will start by taking all the negative exponents and flipping those. That's fine. It's not the way I'm going to choose to do it though, but if you did do it that way, that's okay. You'll still get the same answer. The way I like to start is I like to just combine everything on the top and combine everything on the bottom together first. And so I'm going to start by doing that. So the x to the negative 5 and x cubed on the top, that becomes an x to the negative 2. And on the bottom, I do the 4 plus the negative 7 there. That gives me a negative 3, so that's x to the negative 3. Now, I could just carry down the 4 over the 6, but you notice it reduces. And we're going to have to reduce it eventually, so we might as well reduce the 4 over 6 at the start. When you see them just as numbers like this, they reduce just like a fraction always would have. And so 4/6 becomes 2/3. So we got a bunch of 2's and a bunch of 3's here. Just a matter of seeing what we do with each. Remember that the negative exponents flip whatever it is in the fraction. So that negative 2 is going to flip that x into the bottom. The negative 3 is going to flip that x into the top. Now, when we do that though, we got x cubed and we got the x squared, now like this. Do the whole numbers, the 2 and the 3, do those move as well?
No.
No, they don't. Because they do not have the negative exponents attached to them. And since there's no negative exponent applied to them, they stay where they were. So the 2 is still on top, the 3 is still on bottom. Last step. Simplify the x's. I got x cubed over x squared. Remember, when I divide x's, I subtract their exponents. So 3 minus 2 is 1. So the whole thing ends up just being then 2x, because we don't have to write x to the 1, over 3. So that's our final answer, 2x over 3. Now that we've seen how we can do those, we can make them a little bit more complicated. And that's the layer we're adding on today, is we're going to be simplifying stuff that looks like that first one, but we're also going to have parentheses around it, and that whole thing will be to some other power.
1.
And as you're taking a look at this one, there's 2 different tactics you can take. The first tactic is to simplify everything inside the parentheses first. And so you might start by combining those x's and combining those x's, and then once you combine those, then we can go ahead and combine them between the top and the bottom from there. Then once you've done all of that, then we can apply the 0 power to everything that's on the inside. It's just that when we do that, looking ahead a little bit, what's anything to the power of 0?
1.
And so at the start, the other way we could have done this is we could have just said, okay, well at the start, I'm going to use the power of 0, which is 1. And so we could just say everything equals 1.
Yep.
And so you notice, looking ahead a little bit with these can help you out. Anytime you see something to the power of 0, start by dealing with that power of 0. It's going to make your life a lot easier, because you can just turn anything to the power of 0 into a 1 at that point. Just make sure that you remember to check what's actually to the power of 0. Because sometimes they'll see people get that mixed up. Like they'll see something that looks like this, 2x to the 0, and they'll say that whole thing equals 1, but it doesn't. That's 2 times 1, so it actually equals 2. So just make sure you remember what's the 0 power actually attached to. But of course, that exponent won't always be 0. And so again, we have that same option of either simplifying everything on the inside and then dealing with the outside exponent, or we could start by dealing with the outside exponent, putting that in, and then we could simplify the results from that. They both work, and they both are fine. I personally like to simplify everything on the inside first, and so that's the way I'm going to go ahead and do it here. So basically, you're going to start the same way that we did that very first problem today. Combine the x's on the top, combine the x's on the bottom, and then once we've done that, we'll simplify a little bit from there. And so when you do just that simplification, we now have 6x to the negative 7 over 5x to the negative 10. Now we want to deal with those negative exponents. Some of you at this point will actually look at it in terms of, I now do negative 7 minus negative 10. You can do that, and that will get you to the right answer. But for whatever reason, sometimes that can bend our brains a little bit too much, and it can get us mixed up a little bit. So if you want to make sure not to get anything mixed up, start by just taking care of the negatives by flipping anything that has the negative exponent attached to it. And notice every step along the way, yes, we have to keep the parentheses around it, and it still has to be squared. And then go ahead and do the subtraction of the exponents at that point, so 10 minus 7. And so we end up with 6x cubed over 5. And all of that is going to be squared. Now we actually have to deal with that squared that's on the outside. Now when we say squared like that, that means we are squaring every piece of that fraction. So we're going to be doing 6 squared. We're going to be doing x cubed squared, and we're going to be doing 5 squared. So first step, the 6 squared. Notice the 6 is actually a number. It's not an exponent. Because of that, we actually still just do 6 squared. There's no fancy rule to be applied. So 6 squared is 36. Next up is the x to the third. There it is, an exponent. When we have a power to a power like that, so x cubed that's being squared, remember the rule is that a power to a power means you multiply the exponents. And so that's going to end up giving us x to the 6. A way to see that in case you ever forget the rule, well, x cubed squared means x cubed times itself. Well, and if I were going to do x cubed times x cubed, I would have to add the exponents. That is, I'd have to have 2 3s. So 2 times 3 for that. So that's a way you could remind yourself if you had forgotten that rule. And it's all over now the 5 squared, which of course is 25. That doesn't simplify any more past that, so you're done. So you notice what's different about this one is that it's all to the power of a negative 3 this time. Well, first step though can still be the same if your first step is to just simplify the stuff inside of the parentheses. So start by doing that. Simplify that fraction that's inside the parentheses first. So first up, go ahead and combine the x's on the top, combine the x's on the bottom. Then you can either do the 11 minus the negative 7, or you could go ahead and flip that x to the negative 7 into the top and make it an x to the positive 7. And then you can go ahead and combine the x's on the top to get x to the 18th over 2. Now all of that is now to the power of negative 3. Alright, so this is the critical bit. This is the important part that sometimes people get mixed up on, is how do I deal with it all to the power of negative 3? Because what you don't really want to do is do x to the 18th to the negative 3 and then 2 to the negative 3. It gets ugly. We start getting fractions within fractions and it can be a little bit confusing. It's not good. So the best strategy I've found when dealing with these is actually to deal with the negative and then deal with the 3 after that. So remember, a negative exponent flips something in a fraction. So that's going to take the bottom of my fraction and flip it into the top. And it's going to take the top of the fraction and flip it into the bottom. Which means it's now 2 over x to the 18th. Still all to the power of 3 now. Notice it's a positive 3. The negative part flipped it upside down. But now notice it's a lot easier to work with, because now all I have to do is cube everything that's inside. So on the top I do 2 cubed, which is 8. And on the bottom I do x to the 18th cubed. Remember, a power to a power like that means you multiply the exponents. So we got to do 18 times 3. 54. And so the whole answer then ends up being 8 over x to the power of 54.